Hello, my name is Sarah Lynn, and I will be going over problem 5. This problem says that a metal sphere is launched with an initial velocity of 1.5 meters per second as it leaves the ramp. And it also says that the end of the ramp is 1.2 meters above the floor. Additional information, this ramp is angled upwards at an angle of 20 degrees. So for part A, to sketch the projectile leaving the ramp, we know that this is a projectile motion question, and we know that when the only force acting on this object is gravity, it's going to go down in a down-facing parabola this way. Part B, to calculate the range of the sphere, it tells us that range is the horizontal displacement of the projectile. And if you look back at your kinematics equations, you'll find this equation perfect for this. Because what are you missing? You are missing range, you have initial velocity, and you have the angle, and you have your initial position. But one thing that you don't have is time. So what you want to do is you want to find time. In order to find time, you're going to need to use an equation that allows you to. It's going to be delta x equals to initial position in y plus the initial velocity y times t and 1/2 acceleration times time squared. Now what you don't have right now, or what you need to calculate, is going to be the velocity. Now to find the vertical component of velocity, you're going to use v equals v initial sine theta. Now you know that your initial velocity is 1.5 and your angle is 20 degrees. Now if you punch that into your calculator, you're going to get 0.513 meters per second. And now that you have that, you can go ahead and plug it into the kinematics equation. Initial position is 1.2 meters plus 0.513, which we just found. You don't have time yet. Acceleration, only thing in the vertical direction, is going to be gravity, which is negative 9.8 meters per second squared. And we need to find time. Now, if you plug this into your graphing calculator, you can go, if you have this graphing calculator here, you can go ahead and use the numeric solver. And you're going to get this value right here, which is 0.55. Now getting 0.55, that's going to be your t, because you're solving for t. Keep in mind you have to set this to 0, solving for a quadratic equation. And now that you have time, you can now find range, which is what it asks you for. And that's going to be another kinematics equation. So position, or horizontal displacement, is going to be v initial times t. Now to get the horizontal component of velocity, you're going to use v initial cos theta, again 1.5 cosine 20 degrees. Punching that in, you're going to get 1.409 times t is 0.55, and you will get an answer of 0.77 meters. That's it. Thank you.